Welcome to Section 3, VPC's Exam Prep. In this section, we will cover building our own custom VPC recap. We will then recap NAT and Bastion hosts, as well as access control lists and flow logs. We will give some additional exam tips, and afterwards we will have a summary and a short quiz to validate the knowledge. Building our own custom VPC recap. We will review what we have done with VPCs, how we can create our own custom ones, and the defaults for each. A VPC is a virtual data center in the cloud. A VPC is deployed within a region, and it cannot span multiple regions. But one VPC can span multiple availability zones. VPC is a service that is free to use, but you'll have to pay for the resources that are deployed within your VPC. You must specify a range of IPv4 addresses for the VPC in the form of a classless inter-domain routing or CIDR block, for example 10.0.0.0/16. AWS recommend you specify a CIDR block from the private IPv4 ranges. We have the 10.0.0.0 up until the 10.255.255.255, so the 10/8 prefix. Then we would have the 172.16/12 prefix, as well as the 192.168/16 prefix. The allowed block size is between /16 and /28, and a VPC can only be associated with one CIDR block. A subnet is a component of the VPC and is a range of IP addresses in your VPC. You use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. A subnet must reside entirely within one availability zone, and a subnet cannot span availability zones. By default, all subnets within the VPC can route traffic to one another. The first 4 IP addresses and the last IP address in each subnet, CIDR block are not allowed to be used. A subnet must be associated with a route table, which specifies the allowed routes for outbound traffic leaving the subnet. Newly created subnets are automatically associated with the main route table for the VPC. Then there are internet gateways. An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. You get no availability risks or bandwidth constraints on your network traffic imposed. If a subnet's traffic is routed to an internet gateway, then this means that the subnet is a public one, whereas if it doesn't have an internet gateway attached to its route table, then it is a private subnet. You can have a maximum of 1 internet gateways attached to a VPC. You can either specify it or you don't, but you can only attach a maximum of 1. Then there are network access control lists, or ACLs, which act as a firewall for associated subnets, controlling both inbound and outbound traffic at the subnet level. Security groups act as a firewall for associated Amazon EC2 instances, controlling both inbound and outbound traffic at the instance level. Now, let's recap what happens when we create our own custom VPC. If we go and create our own custom VPC without using a wizard, we will create a VPC. We will need to specify the CIDR block that we want that VPC to have. So for example, 10.0.0.0/16. And then we will need to specify if we want the tenancy of our instances to be shared or not. So we could have dedicated hosts. We can also specify if we want any IPv6 addresses associated with our VPC. But if not, we can just go and create the VPC. By default, when we create that custom VPC, we'll have a network ACL created for us, and that is going to deny all traffic to our VPC To enable it, we would actually have to create special rules to allow traffic in and out of our VPC. And we would get a default security group as part of our custom VPC, which would allow instances from the same security group to talk to one another. Also, by default, we will get a root table, and that is going to be populated with a rule that allows all the instances within our VPC to communicate with one another. So that is a local root, and you can't delete that. To start making our VPC work, we would need to create a subnet, one or multiple subnets. For this, we would need to specify a CIDR block range that we want to allocate to our subnet and an availability zone within the region that we've chosen for our VPC for that subnet to reside in. As we remember, a subnet can only be part of one availability zone. It cannot span multiple availability zones, but you can have multiple subnets within the same availability zone. Also, if we don't specify a specific root table, we would have our subnets be associated by default with the default root table that we get when we have created our custom VPC. If we want to go further and enable internet access to our instances, we could create an internet gateway, and then, as we remember, an internet gateway can be part of one VPC. You can't create multiple internet gateways and attach them to the same VPC. You can only have one internet gateway at a time, so that is a maximum of one. And as we remember, with an internet gateway and a public subnet, the best recommendation is to create different root table than the default one that we get with the VPC, and to add a rule where we're going to allow traffic via the internet gateway from the internet to our instances. And then we would be attaching the public subnet. We would be attaching the subnet specifically to that root table. And afterwards, this would enable us to have internet access to our subnet, but at the same time, you have to remember you need to open up the network ACL and ensure that within the security group you have a rule or multiple rules that will allow HTTP or HTTPS to be filtered in, to be allowed in. And then we remember with private subnets that they don't have an internet gateway attached to them, to their root tables, and then they can retrieve traffic, they can be sent traffic via the instances that we have in our public subnet, because as we've seen beforehand, there is a rule within the root table where all the instances within a VPC can communicate with one another. And if we want to ensure that, for example, we want to be able to connect to different instances via SSH, we would place a bastion host in our public subnet. So for example, over here, we would place a bastion host, which could be an EC2 instance, and we would allow SSH to be open to connect to these particular instances in our private subnets. And we can interact with our instances using that bastion host. It is good practice to harden your bastion host, so that would be the single point of entry for SSH connections. And what we would need to do afterwards is, if we want to actually ensure that packages will get updated for the private instances, or we need some internet connectivity, but only from our instances to be able to pull down new software packages, we would have to create either a NAT instance or a NAT gateway. And this would ensure that we could get updates for our instances. Otherwise, because they don't have an internet gateway attached to them, there is no other way for them to receive any internet traffic and be able to get their packages updated. Now let's recap the default VPC. This is the VPC that is pre-configured by default in your AWS account. It is ready to use, and the VPC size is /16 IPv4 CIDR block. By default, it's going to have one subnet per availability zone, and there's going to be a default security group created and associated with your default VPC, as well as a network access control list. One internet gateway is going to be connected to your default VPC, and all subnets are public and are associated with the main route table with a rule that sends all internet traffic to the internet gateway. Instances launched into a default subnet receive both a public IPv4 address and a private IPv4 address. Instances in a default subnet also receive both public and private DNS hostnames. But if you, by accident or through some other circumstance, you delete your default VPC, you can only get it back by contacting AWS.